The Bridge to Smart Design. Thank you for using Moldex3D eDesignSYNC for Creo. Moldex3D eDesignSYNC for Creo is an easy-to-use interface fully embedded in Creo, providing a seamless workflow from design to Moldex3D simulation. With the interactive platform, it brings unique features and benefits to Creo users. Features and benefits. The seamless workflow improves the modeling and simulation interpretability and encourages design changes for product optimization. The automatic True 3D meshing engine helps users generate high-quality mesh easily and efficiently. The easy-to-navigate user interface and intelligent process wizards support complete pre-processing preparation for precise molding simulation. The full integration with Moldex3D eDesign provides a complete series of CAE solutions such as flow, pack, cool, warp, fiber, two colors, insert molding, and more advanced modules. The complete support of parallel processing for multi-core and multi-CPU highly enhances the calculation speed by utilizing the great power of computing. First, we will introduce the steps to import a model. Now let's start with the first step. After activating Creo, click on File and Open to select an assembly file, then click Open to import the model. Users can select and import any solid part file. After importing the model, please click the Moldex3D tab, which will show on the top part of the menu bar if we have installed Moldex3D eDesignSYNC, to start the pre-processing for the CAD model. All of our moves will be completed under the Moldex3D tab within the Creo environment. As you can see, Moldex3D eDesignSYNC provides a step-by-step workflow to guide our users to complete the pre-processing efficiently. For this model, which is a solid part model, there are two kinds of line structures, runner lines and cooling channels. We will set the part material properties first, and then show a step-by-step setup for the 3D pre-processing of the runners, mold base, and cooling channels according to the 2D line structures. Now we will set up the part material. First, double-click Part to set up the part material. Select the material you need from the drop-down menu for simulation. Moldex3D eDesignSYNC supports a complete material database with more than 5,000 materials to provide our users with many options. Moldex3D also supports fiber reinforced material to perform fiber orientation simulation. For this demo, we choose the common ABS material. Click OK to confirm the setting. You can also click on the Advanced function to see the detailed database information. Now we will go into the part insert process. Moldex3D eDesignSYNC provides part insert features. If your part contains a part insert, you can set the material for the part insert here. Since there is no part insert in this model, we will go to the next step to set up a runner diameter. Setting up the runner diameter. First, you can set the runner parameter according to your model size. We will create a direct gate for this model. This will be a tapered sprue with the nozzle diameter of 3 mm and the gate size at 5 mm. To do this, please double-click on the runner icon. Now, select this runner line. By default, the diameter has already been set to 5 mm as shown here. We change the diameter at the red end to 3 mm and click OK. Now you will see that the solid sprue runner has been created. After completing the steps to set up the runners, we can start to set up the mold base size and material. Double-click the mold base icon to set up its size and material. The mold base setting will provide the recommended default value according to your model size. You can also define the proper size of the mold base according to your design. For this demo, we will use the default value as the mold base size. Then click Set Material to continue. Here we will select the common metal material, P20, as the mold material, then click OK. Next we will talk about mold insert. Moldex3D eDesignSYNC also supports mold insert. This function is the same as part insert and is also optional. Since there is no mold insert in this model, we will go to the next step to set up cooling channel diameter. Setting up the cooling channel diameter. Double-click on the cooling channel icon to set up the diameter. Here you can set the appropriate parameters according to the line structure and its size. You can also design the cooling channels on your own. For this demo, we select the cooling lines and define the diameter of the cooling channels as 10 mm. To complete the setting, click OK. Now we have finished the solid CAD model setting. To build the melt entrance, Moldex3D provides the automatic melt entrance setting function. Here you can activate it to generate the melt entrance. Double-click Melt Entrance to define the melt entrance. Click Yes to create the melt entrance automatically, or click No to define the melt entrance manually. Now you can see the red arrow on the model. This is the melt entrance. Please double-click on the Run Analysis icon to launch the analysis setup. Moldex3D eDesign provides complete analysis capabilities. In this demo, we will choose the full analysis with the analysis sequence of Cool, Flow, Pack, Cool, and Warp. Next, based on your part design and the material you have selected, Moldex3D eDesign will recommend the proper process condition settings to assist you. In this demo, we accept the default value, or you can modify the default value on your own. You can also click the Advanced button to launch a more detailed process condition settings window. Moldex3D will generate high-quality mesh automatically and efficiently. Moreover, we also provide our meshing level control interface, which allows users to modify the mesh resolution according to their requirements. Within the index selection of the mesh, if we raise the mesh level, the mesh density will also be increased. Click Generate HTML Report to automatically generate a port after the analysis. Click Analyze Now to launch the computation. The computation time will vary depending on your model size and the mesh level you have selected. Generally, for a quick, true 3D mold filling simulation, Moldex3D eDesign will finish the analysis within 1 hour. Right now, you can see the analysis in progress. With this model, it will take about 30 minutes to complete the calculation, so we'll skip here. When the analysis is finished, an HTML report with the full analysis results will show up automatically, including the complete molding simulation results such as melt fret time, air trap, and weld lines. You can share the simulation results with partners, executives, or customers to validate your part and mold designs. You can also manipulate all of the simulation results in Moldex3D eDesign. Thank you for listening. If you need more information about Moldex3D eDesignSYNC for Creo, please go to our website, www.moldex3d.com.